Welcome back. So I finished number 6 yesterday with talking about, which answer choice. Cut off a tiny bit at the end. So sorry. So our next one is number 7. So we have the following chart describes the growth of a colony of bacteria. Note that in 1 hour it grows from 1,000 bacteria to 27,000 bacteria. Use the chart to answer the questions below. So it says, does the chart model linear or exponential growth? So we're looking at the time and then the number of bacteria. So if we're looking at this, right, we see, well, the first one we'd have to add 2,000, then add 6,000, then add 18,000. So that doesn't really help. So that means it's going to be exponential. So we're actually multiplying by 3 each time. So that means we have exponential growth because we have a common ratio of 3 because we're multiplying by 3, so we don't write it as a fraction. So it asks, how long does it take to triple? So because we're actually multiplying by 3 each time, right, this does mean that it triples each time. So we are tripling each time, so we just have to see how long it is in between each triple. So it is, right, we go from 0, 20, 40, 60, so it's going up by 20 minutes, right, each time. So that means it only takes 20 minutes for the population to triple. Then it asks how many bacteria will be in the colony after 2 hours. So your choices are, right, so we see time in minutes, 60, so we see 1 hour. You can keep going and tripling until you get to 2 hours, right, or we can use our function. So if we look, we started at 1,000 bacteria and we're tripling each time. So our function would be that we started at 1,000 bacteria and we are tripling each time. So we want to figure out, right, 2 hours. Well, if you look up at our table, right, we're going by minutes, not by hours. So, right, 2 hours. Oh my goodness, this thing is not writing. Right, so you have to figure out how many hours we have. So 2 hours is actually 120 minutes, right? Right, because we do 60 times 2, which is 120. So it's 120 minutes. So we're taking our function but, right, so it's 120 minutes, but, right, we aren't plugging in 120 because we don't want it to happen 120 times. So we're doing intervals of 20 minutes. So we're going to take that and divide by 20 and we get 6. So we're actually going to plug in an x of 6 because that means 120 minutes. This means we've done 6 intervals. Right, because if we kept going in our table, right, we'd have 4, 5, 6. We have 60, 80, 100, 120, because we're adding 20 minutes each time. So if we kept going, right, this is where we're looking at. We are looking at, we've done 6 time intervals. So we're actually going to plug in 6 into our function, right? We wouldn't plug in 120 because that would mean we did 120 intervals. We don't want 120 intervals, we want 120 minutes, which then translates to 6 intervals. So that means we're doing 1,000 times, right? Let's go into our calculator and do 3 to the 6th power, which is 729. Right, and we do that times 1,000 and we get 729,000. Boom. There we go. All right. So number 8, this is our last one. So the following chart describes the growth of a colony of bacteria. Note that in 1 hour it grows from 6,000 to 12,000. Use the chart to answer the questions below. So with this one, right, so we have our intervals, we have our time, and then we have our number of bacteria. So with this one, right, let's see what's happening. Well, in this one, we're actually just adding 2,000 bacteria each time. So it's going up at a constant rate. So this one, that actually means it's linear because we have a common difference of, we're just adding 2,000 each time, right? So it's just constantly adding 2,000. So how long does it take the population to double? So if we can kind of use our table to look at this. So it's not doubling each time, right? We went from 6,000 to 8,000. That's not doubling. So you want to look for within this table, how long does it take for what the starting population was, how long does it take to double? Well, double 6,000 is 12,000, right? So if 6,000, it takes, right, and we're trying to double it, we're going all the way up to 12,000. So we want to see, well, how long did that take? That took 60 minutes or a full hour. However you want to write that, 60 minutes or an hour. Right, in our last one we saw, well, it asked how long it takes to triple. It was tripling each time, so it was every 20 minutes it was tripling and tripling and tripling. And this one we're just adding 2,000 each time, so it's not like doubling or anything each time, so you have to figure out how long that takes. And then it says how many bacteria will be in the colony after 3 hours. So, right, we need to figure out 3 hours, how many time intervals that is. So 3 hours, we do 60 times 3, so that is 180 minutes. But then we want to take that 180 minutes, right, let's look, we go up, we're doing intervals of 20 minutes. So we're going to divide that by 20 because we want to figure out how many 20-minute intervals are in 180 minutes. So that is 9. So, right, that means if we kept going in our table to get to 3 hours, we'd have to go all the way, right, we'd go keep adding 20 minutes, boom, 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 all the way down until we got 180, which would then correlate to 9. So then for our function, right, so let's write our function. So linear is f of x equals mx plus b. So in our case, right, the b is how much it started at. So it started at 6,000, right? Yeah, it started at 6,000 and goes up 2,000 every time. So it's changing by 2,000 each time, and then we started at 6,000, okay? So we already figured out, right, so this is going to be the value we plug in. So if we go down to our function, everywhere there's an x, we're plugging in 9. So we're doing 2,000 times 9 plus 6,000. So 2,000 times 9 is 18,000. And then plus another 6,000, that will put us at 24,000. So that is everything for your 9D notes. So here, let's just write it on. So here, 24,000. So that's everything for your 9D notes. I hope you all are doing well. I miss you so much. Again, I'm going to put at the end of this video, if you need anything, reach out to me. Even though spring break is starting pretty soon, I'll still be available over Remind, email, Teams, however you want to get a hold of me. I am here to help you if you need to talk to me about anything. If you just want to chat with somebody because you're getting bored, if we want to do more video chats, we can do those too. Just let me know. I miss you all. I love you all so much, so much. I hope we get to go back to school this year, and I hope I'll get to see your faces before summer break. Okay, love you. Bye.